is integration with trig substitution, this calculus lesson here. So this lesson shows us how to use our trig substitution with integrals that involve these kind of radicals right here. So a squared minus u squared, a squared plus u squared, and u squared minus a squared. U is always your x stuff, and a is always your number stuff. So this allows to use these substitutions right here from your pre-calculus class, okay? These trig substitutions right here. So cosine squared is 1 minus sine squared, secant squared is 1 plus tangent squared, and tangent squared is secant squared minus 1. All right, so for example, you guys, here's an example. I'll show you one of them right here. So if I had a squared minus u squared, if we let u be a sine of y, then we get, I'm sorry, square root. So square root of a squared minus a squared sine squared. Okay, so if I factor out a squared right here, it gets me over to here, 1 minus sine squared, and 1 minus sine squared is cosine squared, and so when I square root that, you get a cosine y. Okay, and you'll find out this trick will work on lots of trig substitutions here. So if you have a squared minus u squared, then we're going to let u be a sine y. And then I just showed you that the square root of a squared minus u squared is going to be a cosine y. Now I'm not going to show you these ones, but you do the same and then use those trig substitutions back what I just showed you. If we had a squared plus u squared, then we let u be a tangent y. And then we get a secant y with our substitution right there and our simplifying. Okay, if we had u squared minus a squared, then we'd let a equal secant y, and we'd get plus or minus the tangent of y. Okay, just remember that u is your x stuff and a is your number stuff. All right, let's try a few of these, you guys. Evaluate each integral. So here's one. So this one is 9 squared minus x squared. Okay, remember 9 is the number and x is the x stuff. So this is going to be a sign substitution. So we're going to let x, which is our u in this case, let x equal a sine y. Well, a is this thing, the square root of this number right here. So it's 3 sine y. Okay, if I divided both sides by 3, you get sine of y equals x over 3. Oh, I have it right here. So x over 3 is opposite over hypotenuse, and a little Pythagorean theorem right there. We get 9 minus x squared, and the third side is always going to be this stuff right here. Okay, that's why we're doing this trig substitution. All right, so that means that this radical is going to be coming out as 3 cosine y, where it's a cosine y right there. Okay. And then so if I differentiate, dx is going to be 3 cosine y dy, and then x squared, I need to get x squared right here. So if I square both sides right here, because there's an x squared right here, so that's why I put an x squared, it's going to be 9 sine squared y. So let's go ahead and substitute all that stuff in. Okay, so it gets all substituted in. Okay, and then these 3 cosine y's are going to cancel right there. And we're going to get 1 over sine squared. It's 1/9 right there, which is cosecant squared. Okay, and the integral of cosecant squared is cotangent. So I'm sorry, negative cotangent. So now this is in terms of y, so we got to convert this back in terms of x because it started with x. So cotangent is, since tangent is opposite over adjacent, cotangent is adjacent over opposite, and I'm going to go ahead and use this right triangle right here. So adjacent over opposite is going to be this over this right here, so that's what's going to get substituted in back right there, and I think I have that on the, oh, there it is right there, and then I just shrunk it up right there, and then so I just combined the 9 and the x right there, so there's the final answer right there. Okay, so there's an example of trig substitution. Let's try another one here. Okay, this one is with the plus right here, so this one we're going to do a tangent substitution, and tangent and secant are always going together, you guys. So if we do a tangent substitution, it's going to come out secant right there, except u is equal to 2x, you guys, and because it's the square root of this, and here's a, the square root of this right there. Okay, so I'm following this, so u equals a tangent of y, so u equals a tangent of y, or 2x equals tangent of y. Okay, so let's go ahead and get our right triangle right there. Remember, this is opposite over adjacent, so 2x over 1, 2x over 1, and look, the third side is always this piece right there. Okay, so the a squared plus u squared is going to come out as a secant y, so it's going to come out as 1 secant y. Okay, all right, so and then when I differentiate, you guys, I get dx is equal to 1/2 secant squared of x. So let's go ahead and substitute all that stuff back in right up there. and I get 1/2 secant squared y dy over secant y, and then that go ahead and divides that into that. And then the integral of secant of y is the natural log of absolute value of secant of y tangent of y. Okay, and then we got to convert this back into x. So the secant of y, since cosine is adjacent over hypotenuse, it's going to be hypotenuse over adjacent, and then tangent is opposite over adjacent, so it's going to be 1/2 natural log of here's hypotenuse over adjacent, here's opposite over adjacent, and then plus c. Don't forget your plus c. Okay, and you guys saw in the last video I forgot my plus c, so I forget it every now and then too. Okay, here's another tangent substitution. We got to recognize that this is the same as the square root of x squared plus 1 cubed. Okay, so u is going to be x, which equals a tan y, which is 1 tan y. Okay, so dx is secant squared, and then the radical will simplify to secant of y, and there's my triangle right there. And let's go ahead and substitute in everything. And then so remember dx is secant squared, and then this becomes secant of y cubed right here. This radical becomes secant of y cubed. Okay, so this is my radical, my square root right there. Okay, there's my secant of y cubed right there. All right, you got it? So you get the integral of dy over secant of y, which is the integral of cosine y, which is simply sine of y, and then go ahead and get your opposite over hypotenuse up here to get sine of y, and there's the answer. Okay, it's not too bad once you get the hang of this. Just a lot of practice just helps you guys. Okay, here's another one, you guys. Okay, so we're going to go ahead and do the secant substitution right there. And so x equals root 3 secant of y right here. And then here's my right triangle. Remember, secant is hypotenuse over adjacent, so it would be x over root 3 when I divide both sides by root 3 right there. Okay, notice this is always, that third side's always that radical piece right there. And then, so dx is, there's dx, and then there's my radical, so we're going to go ahead and substitute all that in. And and before I do all the substitution, since this is we're bounded with these numbers, let's go ahead and substitute root 3 in and 2 in into this guy right up here. So when I substitute that in, x, let's see, when x equals the lower bound right here, then I get root 3 equals root 3 secant of y, or just secant of y equals 1. And since the cosine of 0 equals 1, then the tangent, or the secant of 0, also equals 1. All right, and let's see, and then since when you plug in x equals 2, you get secant of y equals 2 over root 3, so you get pi over 6. So I'm going to change my bounded by, my lower bound is going to be 0, my upper bound is going to be pi over 6. So here's, this becomes this right here with all my substitutions. Okay, gets a little messy. I think you can follow along though. And then clean it up, you guys. These guys are going to cancel right here, and we're going to get tangent squared, pull out that root 3. Tangent squared is secant squared minus 1, and the integral of secant squared is tangent. The integral of 1 is just y, and then go ahead and plug them in. And I get 0.0931. Okay, and then I'll do one of your homework questions for my class right here, number 43. This is one I'm going to assign. So here's the trick on this one right here. Change that 8 to plus 4, because then you get this perfect square trinomial right there, which factors to x plus 2 squared. And then this is going to be a trig substitution right here using your tangent. So when you plug in tangent, my x plus 2 is my u, equals 2 tan y, a tan y. Okay, so the x plus 2 is going to be 4 tangent squared plus 4, and then we substitute that in, and we get 4 secant squared y. All right. And then let's go ahead and sub all that information in right there. Oh, and since I have an x right there, then x is going to be 2 tan y minus 2, so that goes right there. And everything gets substituted in and canceled out, and you're going to do the integrals of those guys, and I get the integral of secant squared secant tangent is secant, and the integral of secant is the natural log of secant plus tangent. Okay, and then go ahead and plug in your right triangle right there. Sorry, it's up here. Here's my right triangle right there, and so I did the secant right there is this mess right here, and then here's my secant, and here's my tangent using this right triangle right there, and there's my final answer. Okay, fair enough, you guys? All right, if you are in my class, I would assign that for your homework. Take care, you guys.